Hello viewers, greetings to you and welcome to my channel. All right, if I have a 12 volts 200 amps hour battery and I want to charge it using solar panels, how many solar panels do I need to charge this 12 volts 200 amps hour sealed battery? It is a sealed battery, not a lithium battery or a tubular battery. So how many panels do I need? So at 100% DOD, that is, if you want to discharge the battery, your DOD, you want to make use of 100% DOD, how many panels will you need? Remember, for a lead acid battery, it is not recommended that you completely discharge the battery. So if you want to use 100% DOD, you should know that your battery will die fast. The lifespan of that battery will be reduced because the discharge rate is very high. Every day, your depth of discharge, the amount of energy you're taking from that battery is high. So the battery will die fast. So I will show you how many panels you need for 100% DOD, 50% DOD, and 75% DOD. So for 100% DOD, the first thing is that you need to know the energy that is stored in that battery. The energy stored in a 12 volt 200 amps hour battery is 12 volts multiplied by 200 amps hour. That is the voltage multiplied by the capacity. The voltage of the battery is 12 volts and the capacity in amps hour is 200 amps hour. So when you multiply, you have 2,400 watts hour. Remember, we need the energy to size the solar panels that will be needed to charge the battery, or that will generate the energy that will be stored in the battery. So if we have our energy at 2,400 watt hour, the next thing is that we are dividing this energy by 0.65, which is the performance ratio of the solar panels, because ideally it is not possible for solar panels to generate constantly at to generate 100% of their rated capacity constantly from morning till evening. It is not practical because of shading, temperature, and other effects that we cannot control. So if we divide 2,400 watt hour by 0.65, which is the performance ratio, this is what we will have: 3,692 watts hour. Now we are going to divide this 3,692 watts hour by 5. The 5 here is the peak sunshine hours. How many peak sunshine hours do you have in your area? So I'm using 5 hours. That's the availability of sunshine in a particular area per day. So I'm using 5 hours. Some places, some areas, or depending on your geographic location, you may have 6 hours of sunshine every day on average. Then some 4.5, some 4 hours, some 3 hours, depending on your climatic conditions. So 3,692 watt hour divided by 5 will give us 738.4 watts. Remember, this hour will cancel this hour. So what we are having is watts. So we need 738.4 watts of solar panels that will generate the energy that will be stored in this battery at 100% DOD. So to know the number of panels that we need, how many pieces, we are dividing it by the power rating of the panel. You may decide to use 200 watts, 150 watt, 250 watt, 300 watt, or 350 watts. But in this case, we are using 180 watt solar panel. So we are dividing this by 180, which is 738.4 divided by 108. The wattage will cancel. So what we have is 4 pieces. 4 pieces of 180 watts solar panels will be able to generate the energy that will be stored in this battery every day if you are discharging the battery at 100% DOD. So just hold on as I will show you how the number of panels that are needed if you're using 50% DOD. All right, at 50% DOD, the number of panels we need, first we will need to calculate the energy that is stored in the battery, which is 12 volt multiplied by 200 amps hour, which is the same 2,400 watts hour. So at 50% DOD, what we need is 2,400, this energy in watt hour, 2,400 multiplied by the DOD, which is 0.5. 50% is 0.5. 2,400 multiplied by 0.5. Our energy will now be 1,200 watt hour. You can see that it has reduced. So 2,400 multiplied by 0.5 will give us 1,200 watt hour. This is if you're using 50% DOD for that 200 amps hour battery. So the 1200 watt hour divided by our performance ratio 0.65 will give us 1846 watt hour. Divide by the peak sun hours, which is 5, we will have 369.2 watts. So if we divide that by the power rating of our solar panel that we have decided to use, which is 180 watts, we will use 2 pieces. Remember the other one, at 100% DOD, we need 4 pieces of 180 watts to generate the energy that will be stored in a 12 volts 200 amps hour battery. Now at 50% DOD, we are using 2 pieces of 180 watt solar panels. So I'm going to show you for 70% DOD. All right, at 70% DOD, you need 3 pieces of 180 watt solar panel. You follow the same process. At 70% DOD, you multiply by 0.7. If you're using 60% DOD, you multiply by 0.6. If you're using 30% DOD, you multiply by 0.3. So after that, you divide by your performance ratio, then by your peak sun hours, and by the power rating of the solar panel you want to use. You can use any size. If you want to use 300 watts, you want to use 200 watts. But if it is a 12 volt system, I think you can use 150, 180, 200, 280, 220 watt solar panels. You have 2.8, approximately 3 solar panels. That is 3 pieces of 180 watt solar panels at 70% DOD. So if you're designing a solar system or sizing the solar panels that will be needed to charge a lithium battery, it will be different, because the number of solar panels will be different for a lithium battery. So in my next video, I will show you how to calculate the number of solar panels that are needed to charge a 12 volts, maybe a 12.8 volts, 200 amps lithium battery. Thank you for watching.